Hello, my name Dia. This is episode 7. Today we'll find the pseudo-foci of ax to the fourth, where a is the stretch factor. Essentially, this will have the same video formula as the ax cubed episode where we applied the 5-step rule to a function because we want to get used to those steps. In the end, when we will have completed all 5 steps, I will remind you of the significance of the acquired values from the steps because I still feel like the mathematical relationships of the steps are still unclear, and because I don't want a video that is full on algebra. Lastly, I will also be much briefer in this video, so expect this video to be less than 10 minutes. Again, I encourage you get yourselves a pen and paper on solving these steps so your algebra brain may acquire smartness and brain wrinklage. Starting with step 1, find f prime x, f prime prime x, and f triple prime x. Like last time, we used the power rule thrice to acquire our 3 derivatives, where we have ax to the fourth, which then becomes 4ax cubed, which then becomes 12ax squared, and then 24ax. These monomials are our original function and derivatives. Next, we move on to step 2. Solve for 3f prime x, f prime prime x squared equal f triple prime x times f prime x squared plus 1. Now that we have our derivatives, we plug those consecutive f's where we have 3 times 4ax cubed times 12ax squared equals 24ax times 4ax cubed squared plus 1. Expanding the two enclosed squares from every side, we get 144a squared x fourth and 16a squared x sixth. The 144a squared x fourth can be divided by 24ax, where the left factor becomes 6ax cubed. Next, we multiply the 6ax cubed by the remaining left factors, where we have 72a squared x sixth. This then combines with the like term 16a squared x sixth, where they subtract to 56a squared x sixth. Now, we divide the 56a squared to 1, where we are now left with x to the sixth equals 1 over 56a squared. Following that, we take the sixth root of x, where our x value becomes the sixth root of 1 over 56a squared. Since a negative to the sixth power is positive, our answer has a plus minus. Lastly, if you remember how exponents work, this also evaluates to plus minus 56a squared to the power of negative 1/6. This is our x value that we will use in step 3 and 4. Step 3. Solve for x in the x component, x minus f prime x cubed plus f prime x over f prime prime x. Alright, let's turn the f's into what we have. So it's x minus 4ax cubed plus 4ax cubed over 12ax squared. Doing the cubed parenthesis, it becomes 64a cubed x to the ninth. Next, we divide both fraction terms by 12ax squared, where they become negative 16 thirds a squared x seventh minus 1 over 3x. The minus on the fraction applies to both terms. After that, we need an x sixth, so we factor an x to both terms, where we have x times 2 thirds minus 16 thirds a squared x sixth. With an x sixth, we can unsub that x sixth to 1 over 56a squared. The a squared, the 16 thirds, and 1 over 56 cancel and simplify to 2 over 21. The inner term subtracted 12 over 21, which simplifies to 4 over 7. Unsubbing the last x, we then end up with 4 sevenths 56a squared to the power of negative 1/6. And this is our x component, or simply our answer to step 3. Alright, step 4. where we have to find the y component, which is f of x plus f prime x squared plus 1 over f prime prime x. Taking care of the f's, we get ax⁴ plus 4ax³ squared plus 1 over 12ax². Doing the squared parenthesis, it becomes 16a² x6. We have an x6, but we can simplify it further. So we multiply the ax⁴ by 12ax² over 12ax², so it joins the fraction, where it becomes 12a² x6 in the numerator. Adding this term to 16a² x6, they sum up to 28a² x6. Now, we unsub the x6 where it becomes 28a² times 1 over 56a². These simplify to just 1/2. Adding the 1 to this, the numerator becomes 3/2, and simplifying further, we get 1 over 8ax². The power of x is -2 since it's in the denominator, and our x value has a -1/6 power. So, when we unsub the x, the -1/6 multiplies -2, where 1 over x² equals 56a² to the power of 1/3. Alright, one thing left. We still have an a on the denominator, for a denominator a outside the 1/3 power, inside its denominator a³. With that, the a² and the a³ cancel to just a on the denominator. Conclusively, our y component results to 1/8 56 over a to the power of 1/3. Step 5 is the easiest step. We just compile the step 3 and 4 values into a coordinate, where we then have 4/7 56a² to the power of -1/6, 1/8 56 over a to the power of 1/3. Alright, this is the coordinate for the positive x value. We then do the negative 56a² to the power of -1/6. Doing so is simple. If you remember the shape of x⁴, you will know that it is an even function where some point 1, 1 has the negative x counterpart, -1, 1. The same applies to pseudo-foci, where the negative pseudo-focus is -4/7 56a² to the power of -1/6, 1/8 56 over a to the power of 1/3. Alright, now let me explain what the values from steps 2 to 5 mean. The value we got on step 2 is an x value to a point on ax⁴. This point is where we draw a normal line through it. Now, there exists some point on the normal line where its coordinate is determined by step 3 and 4. This coordinate is our step 5 answer, which finally is our pseudo-focus. Additionally, when we enable our normal map, we can see that the coordinates we got must be true because the points are at the cone's tip, which defines a pseudo-focus. For a final touch, let's enable the animation that stretches the equation. Take a look. Alright, that's that for episode 7. I'm sorry if this may not be the usual funny and cheerfully animated episode. Let's just say I'm testing the balance of comedy and brevity of script writing on this video, like I mentioned on episode 6.9, which is
nice.
Maybe on episode 8 I'll be full-on comedic so it won't be boring. Alright, I think Michael Rosen's the only joke in this entire video. See ya, folks.